Hello geometers and general seekers of truth. In this video we are continuing on from the previous one where we talk about making a triangle when given two fixed lengths and one fixed angle. And we know from the previous video that when the fixed angle joins the two fixed sides, there can only be one congruent triangle that's constructed. So what if this time we don't join the two sides with the angle? Let's see what happens. So I will start this construction similar to the last one. I'm going to start it by making a point here. We'll call this point A. And I'm just going to extend this with my straight edge. And now I'm going to replicate this angle right here, just like I did before. And I'm going to go a little bit quick on this because I'm assuming that you've done this many times before and you're well versed. If you're not, look back at some of the previous lessons on how to construct and replicate angles. So I'm going to take the needle, put this on A, pencil on Y, transfer it down. That point right there is basically Y. Needle on A, pencil on X, transfer it over. Let me check one more time here. There we go. Needle on A, pencil on X, transfer it over. And I know that X has to be somewhere on that arc, but in order to pinpoint the location of X, needle on Y, pencil on X this time, and then transfer it over here. Double check one more time. Needle on Y, pencil on X. And there we have it. I am going to extend this side length. And I've successfully replicated this angle to be congruent to this angle up there. Alright, so what I'm going to do next is replicate AC. So I'm going to put the needle on A, the pencil on C, like so. Transfer it over. Draw myself a nice arc up there. Extend this side right here until it intersects to that arc. And this is going to be the location of point C. So this segment AC and this segment are also congruent because we constructed and made it that way. Now finally, what I do not want to do is put AB along here. That would produce the same situation as what we had before. So what I'm going to do instead is measure this segment AB, but this time instead of placing the needle on A, I'm actually going to place the needle on C. And I'm going to draw this arc right here. Let me do that again with a better compass. Needle on A, measure it to B, and then transfer it over here. And that's the location of point B. And then I'm going to take this ruler and place it there and say that this segment BC is precisely congruent to the segment that I had before. Right, so it lines up very nicely. Okay. Now you see that this is what the triangle I had before, using where the angle joined the two sides. It's a totally different triangle. Okay? So if we don't have the angle join the two sides, then we can certainly make another triangle. But I will actually show you that we can make yet another triangle if we don't have the segment join the two sides. So remember B from before. Remember this last segment that we did here. I actually have another option that I can use. I can still put the needle there, and I can make this arc right here. So you see that the arc that I draw actually intersects this side twice. So another option that I have is to make this triangle. Okay. So if you look at the blue triangle here, I'm kind of coloring in, it actually matches the description of the problem. We use this segment here AC, got it. This segment here AB with 2 tick marks, got it. I guess I'll call this here B2. All right, and it uses this angle, got it. So this is the blue triangle. All right. Now the bigger one, the big red triangle that I outline over here, I guess I'll outline this in yellow just so that you can see it very, very clearly. Right, this big triangle here also matches that description. It has the angle, got it, the side length, got it, and the second side length. So you see, when the angle does not join the two sides, we can make multiple non-congruent triangles. And that's worth writing down. So when the fixed angle does not join the two fixed sides, we end up with two non-congruent triangles. So this case is called side angle side. I'm sorry, side angle. In other words, the way we name this is side, side, and then an angle, or side, and then an angle. And this is non-congruent. Okay, this is not a valid method to show congruence. When the angle joins the two sides, this is called side angle side, because you have a side right here, an angle right here, and then another side. Okay, when the angle joins the two sides, this is a valid method for showing congruence. So this is actually a postulate. Okay. And side angle is a very common mistake that people make, and it actually is not valid at all. So hopefully in these constructions you see how to show another method for showing that two triangles are congruent, and more importantly, a method for showing that for a very common pitfall. Thank you for watching, and have a wonderful day.